Greeting on project presentation on subject of neural machine translation. Well, our goal is Ukrainian English translation using NMT systems based on SEQ to SEQ model with RNN lawyers. Yeah, it sounds a bit complicated, but during the presentation I will explain the essence of these things. So, as a dataset, we will use a set of Ukrainian and English pairs of sentences with step separators obtained from an open database of sentences and translations. Well, today neural machine translation mechanism can be used as a basis of professional translation, and recent advances in technology have allowed more and more multinational institutions to use NMT mechanism to support internal and external communication. Well, what is machine translation? Machine translation is the process of using artificial intelligence to automatically translate content from one language to another, without human input. In other words, a computer program translates text without the need for human translator to intervene. Well, what types of machine translation is? First one is rule-based, now mostly obsolete, because it relies on linguistic information about the source and target languages. Next one is statistical, because it works by analyzing enormous amounts of existing translations, and multilingual corpora and looking for statistical patterns in this input. And the newest one is neural. It uses neural networks to translate source text to target text. And let's look a little bit closer to NMT. It's a state-of-art of machine translation approaches that utilizes neural networks techniques to predict the likelihood of a set of words in sequence. This can be text, fragment, complete sentence, or with the latest advances, an entire document. Well, in this project we will use SEQ to SEQ model. It's learning about training models to convert a sequence from one domain to sequences in another domain. There are multiple ways to handle this task, either using RNN or 1D convents, but we will use rnns. Well, a typical SEQ to SEQ model has two major components. First one is encoder, one RNN lawyer, which processes the input sequences and returns its own internal state, and another RNN lawyer named decoder. It trained to predict the next characters of the target sequences, given previous characters of the target sequences. Next one is the system analysis and the UML diagrams, especially use case diagram, first one. It is initial conceptual model of the system in the process of its design and development. It consists of actors, users and the relationships between them. Next one is the activity diagram. The activity diagram is a graphical representation of the performed set of actions of the procedural systems, and the variation of the state diagram in this is considered. Next one is considered. The diagram of components is contrast of the previous considered diagrams, because it describes the features of the physical representation of the system. Well, let's look at our methods and technologies. We used Python as a programming languages, Jupyter Notebook as development environment, and Keras as a programming toolkit. Let's look a little closer to Keras. It's a deep learning API written in Python that returns on top of the TensorFlow machine learning platform. And here's next advantages, like simplicity, because it's reduced the developer's cognitive load, so you can focus on parts of the problems that matter. Flexibility, it's used the principle of progressive disclosure of complexity. And the last one, power. Keras provides power performances and scalability, because it's used by organizations and companies including NASA, YouTube, and Waymo. Well, let's describe the performance statistics. We use the model checkpoint callback, and it is used to conjunction with model feed training to save the model or scales at some interval, so model or scales can be loaded later to continue training from the saved state. As we can see in the chart above, the loss confirmation ceased to diminish as after 25 epoch. And let's look at our results. So that's all for me now. Thank you for your attention.